access list configurations expanded. The expanded part is we're expanding on the original 640 801 material for the 640 802, which is the new CCNA test. There have been some additions to the new test, one of them being sequenced access lists. Sequence access lists are available as of iOS release 12.2, and it gives us some more flexibility with the filter decision as far as how we order the access list and actually the ability to be able to delete individual entries. Additional access lists we're going to be going over are dynamic, reflective, and time-based access lists. But we're going to first go in and talk about sequenced access lists, as that is a bigger part of the new CCNA test. So let's go in and take a look at how these access lists function. Sequence access lists, again, available with iOS version 12.2 15T. Sequence numbers can be added to the individual access list statements, allowing us to reorder access list statements as well as delete individual access list statements. Prior to this, we had to remove the entire access list. Here's a sample configuration on this. IP access list, and notice when we're going to create this, the IP access list, that's what we do when going to create a named access list. So we're actually kind of creating a type of named access list with a number instead of in the name. So we're just using the number 110 as the name of this particular access list. Extended means it's an extended access list, which again filters based on source, destination, protocol, port number, as opposed to just source IP address on a normal access list. And what we do, the only difference now is we add a number to the beginning of the statement. Now typically in environments where we're doing sequencing and things like that, the initial timeout when we create the access list, originally we're going to go with numbers like 10, 20, 30, 40, 50, and so on. And the reason we do that is because if we decide later on that we like these two statements but we want to add another line in between, we've got 9 numbers in between, 11 through 19, that we can use to add additional entries between these two entries. So what I want to do now is I want to go in and take a look at configuring these access lists on a router. So here I am. I have a hyperterminal session open to a router. What I'm going to do is I'm going to do the show version command just to make sure I have an operating system that supports these access lists. And again, it's got to be at least 12.2 15 in here. I've got 12.3, so I know I can go in and create access lists with sequence numbers. So I go to global mode just like every other time, and now if I want to do this, I have multiple options when I go to create my access lists. But again, if I go IP access list, this is creating a named type of access list. And what it's going to want is, okay, what type of access list are you creating? And typically we're going to go with the standard or extended access list, especially for the CCNA program. So I'm going extended, and now it wants the name or a number to go along with the access list. So I can just go a number between 100 and 199. I could actually give it a name. And again, the nice thing about this now is I'm going to be able to add sequence numbers. So I'm going to call it access list 110. Enter. Now, if I use a question mark, prior to this version, newer version of code, I'd have permit deny in there and a no. I wouldn't have all these different types of access lists, like dynamic, evaluate an access list, things like that. Remarks also weren't available in older operating systems as well. Obviously, permit and deny were definitely there. So what I can do now is, if you notice, the first thing in line is a sequence number. Access lists can get pretty long, but here is the length of the numbers I can put in here. So that's 2,147,483,647. I can go up to that. So if your access list is getting that long, you are doing something wrong. So what I'm going to do is I'm just going to start with the number 10. So I can go 10, 20, 30, 40, 50, 60 as I add entries to the access list I'm creating. So here's my access list I've created, and it's access list 110. I've got some permit statements here. I'm permitting FTP traffic to this particular host, and then I am blocking all other FTP traffic. So if it's not a part of one of these subnets, or network addresses actually, if it's not part of one of these networks, then it's not going to have access, and then I'm permitting all other traffic. So here's my access list I created. Now when I created this, I did use sequence numbers. I went into extended name access list mode, and I put 10, 20, 30, 40, 50, 60. So this would be 10, 20, 30, 40, 50, 60. I just can't see it here. This is what I'm looking at when I do a show run. If I do a show access lists, I can see my sequence numbers here. So I want to use the show access list command. So here I see 10, 20, 30, 40, 50, 60. And what's going on with this access list again is I'm letting subnets 192.168.10, and it's actually networks, not a subnet since it's class C here, network all the way through network 192.168.40. So 1, 2, 3, and 4 networks can get to this particular host of 192.168.99.51 FTP. So it can set up an FTP session to this particular host from any one of these 4 networks. Then I denied all other traffic going to this particular host at this particular port. So I'm denying any other host from being able to set up an FTP session with this particular server. And then I'm permitting all of the traffic on the network. So maybe this is my only FTP server, whatever. I'm permitting everything else. The nice thing about this is, let's say I decided I wanted to deny one particular host on the subnet 192 or network 192.168.1.0 from accessing the FTP server. Maybe he's just uploading a bunch of movies there, or I don't like the guy, or what. Whatever the reason, I can block one particular user without having to go in and reconfigure the entire access list. I'm just going to use a sequence number that's in between the 10 and the 20. So to block a user from this subnet right here, I'm going to go into global mode, and what I want to do is I want to get back into that access list configuration. So IP access list, extended, 110, and now I have to determine where I want to place this entry. So if I'm going to be blocking a host on this subnet, I would have to put it prior to permitting all FTP traffic from that subnet. Or if I'm going to block it from this subnet right here, 192.168.30, I say subnet, but again it's a network, I'm going to have to put it prior to that entry in the access list statements. So let's go ahead and just block someone from 2.0 network here. So what I need to do is I need to put it prior to the 20. So all I have to do is use a number like 15. Deny TCP host, and I'll pick a host with this IP address. I don't want to use 51, let's use 57. Going to host 192.168.99.51 at port, and then the FTP port to establish the session. Control Z, I'll save it. Write memory. Show access lists is the command we want, and I can go in and see that I have successfully added an entry. The reason this is so awesome with the sequenced access list is prior to the sequenced access list, what would happen is this new entry would be at the very bottom after the permit IP any command. So what would happen is this entry would never even get looked at. Now what it does is it looks at the packet. So if this guy tries to connect to the FTP server, it'll look at the packet and go, are you network 192.168.1.0? No. Are you host 192.168.2.57? Yes. Are you going to this destination IP? Yes. Is it at FTP? Yes. Sorry, I have to deny you. If this were at the bottom, what would happen is it'd go, if this line was not there, and actually let me show you how I can easily remove this particular line. I can just go back into, actually let me just use my up arrow here. All I have to do is go no 15, enter, Control Z, show access lists. So I don't have to type no 15, deny, blah, blah, blah. I just go no 15 and the whole line is gone. Now what will happen when he tries to connect is it'll go, okay, are you from subnet 192.168.2.0? First it'll see this. It'll go, you're not part of network 192.168.1.0. Are you part of network 192.168.2.0? Yes. Are you going to this host? Yes. You setting up an FTP session? Yes. I'm going to permit you. So it'll allow that traffic to go through. So if that statement were at the bottom here or anywhere after this permit statement for that network, it wouldn't work if I were trying to deny him, because he'd be through already, and as soon as an access list entry has matched, it does the appropriate action based on that entry. It does not look at the rest of the access list. So sequenced access lists are awesome because we can go in and reorder things easily without having to get rid of the entire access list. So let's go in and take a look at some additional access lists that we can create now with later versions of the Cisco IOS. Here are the additional types of access lists you should be familiar with. Dynamic, reflective, and time-based access lists are covered as well with the new CCNA test. Dynamic access lists allow prevention of traversal, meaning you can pass through the router or you can't pass through the router until you've telnetted and authenticated from the router. What that means is when you're going to access, let's say you're the client over here and you're going to access resources on this particular server, what's going to happen is you're going to establish a telnet session to this router. Once you've established a telnet session on this router, it'll go ahead and authenticate you and allow traffic from your client machine to pass through the router to access this server. So unless you telnet to this router and establish the session allowing you to go through the router and basically authenticate yourself, the router will stop your traffic from accessing the server. So it's they call it a lock and key. Here's the lock, here's the key. So what has to happen is you have to go in and authenticate yourself, basically unlock the door that allows you to get through and get to this server. So that's a dynamic access list. An additional one is a reflective access list. And with this one, filtering rules can be applied to the session or to the user based on the session layer information. Let me go back to that diagram, clean it up, and explain what I mean by session layer information. Now, with the reflective access lists, also referred to as reflexive, I've seen both accounts on Cisco's website, and researching online I've seen it referred to both ways. If you're learning how to configure these, it's better to use actually reflexive, but in the study guide that I have for this new CCNA from Cisco, they call it a reflective access list. So either way, you're good, but if you're doing some searching on their website, you want to call it reflexive access list when you're doing your searching. What this does is we would have a reflective access list applied on the outbound direction of this interface right here. We could apply it here or we could apply it here, depending on our environment. So let's just say we're applying it on our WAN interface. So here's the WAN between us and some resource. So we have a reflexive access list that we apply going out. And our main access list that's filtering all of our traffic is an inbound access list going in. So traffic coming from the outside world, we have this inbound access list protecting us. So what we can do is, instead of leaving doors open all the time for all the traffic we're going to from all those servers, all these ports and holes in our inbound access list, what we can do is we can have entries dynamically created when we need them. So as a client, what would happen is I would try to go in and access this particular server or resource on this server, whatever. My source IP might be 10.1.5.8, and I might be accessing a resource on an IP 20.2.3.12. Let's say there's where the resource is located. I'm just going to use a random port number. Say I'm accessing, I don't know, port 8130, a service on this server that I'm accessing a port. Now, my source port might be coming from port 3096, something like that. So what can happen at this point is when I go out to the network, right now any traffic coming from this server IP is going to be blocked on my inbound access list. I have a reflexive access list created going out, and I've also what's called nested the reflexive access list on the way in. So what happens is the router, when I'm going out, it looks at the source and destination traffic to get the session information. And so what'll happen is it'll dynamically create an inbound access list. So it'll dynamically add an entry on the inbound access list in a temp directory, allowing traffic coming from this server going to my client just when I need it. And what you would do is you would go ahead and set a session timeout. So let's say after 2 minutes, this session would end. So what's cool about this is traffic coming from the server is not going to be allowed through my inbound access list. However, when I initiate the connection going out, the reflexive access list adds a dynamic entry to the inbound access list itself, allowing the traffic from the server to go in and hit my client machine. Once I'm done, that entry on the inbound access list times out. So if somebody were spoofing the source IP or something here, or trying to get back in with the source IP, that session would be ended and their opportunity to get into our network would be done. So reflexive access lists can add some security to our network instead of just leaving certain ports and open on our inbound access list. Let's talk about a timed access list. That one is fairly self-explanatory. Back at my slide, a little bit more cleaned up, I just want to touch base on the time-based access lists. It's very similar to extended, except it is based on time. This is a clock I am drawing. Big hand, little hand right here. So key thing about this is you might want to allow a particular type of access to your network between the hours of 8 a.m. and 10 p.m. But after hours, you might want to shut that down because people shouldn't be accessing that data other than their normal work hours. Something like that you can use a time-based access list for. So what I want to do real quick is just go through the steps required to create a dynamic, a reflective, or reflexive access list, as well as a time-based access list and a couple of the commands you would use. Nothing you need to be an expert on, but you should definitely be familiar with the availability and the functionality of these types of access lists. Let's start with dynamic. So the steps to create a dynamic access list, just a few of them. You create the dynamic access list. You're going to apply the access list to an interface. Specify an authentication method. You have 3 different types of authentication methods. You can use an external server like TACACS. You can use a local username and password, local authentication, where you actually create a user account for the user, and then the simple local authentication where you just set one username and password that everybody uses. Least secure, most secure. I just did a basic setup for this, and then the fourth step, obviously, well, not obviously, maybe not. You enable the ability for temporary access for the temporary access list creation by using the auto command. Because again, what happens after you log in to the server via Telnet, you're going to get a session that allows you to pass through the router to get to the resource on the other side. So here, we're creating an access list. We're permitting TCP, any host. Since we're applying it to the external interface here, we're allowing Telnet in to that IP address. We've got to allow the Telnet session to take place. Second part is we add the dynamic entry to the access list, and that's creating the dynamic access list. Access list 110 dynamic Palestra test list. This is the name of this access list. Timeout 120. This 120 is the absolute timeout. So max timeout here of 120, and that is the absolute, meaning even if the session is still active after 120 minutes, it's going to kill it. Now there are some things you can do to get around that, but we're just going to set this time at 120, which is 2 hours for that session to be active. And we're permitting all traffic. So once they're verified through Telnet, all types of traffic are going to be able to go through the router to get to those resources on the other side. Again, remember, here's our router. We're setting it on our WAN interface right here. So as an outside client comes in, they telnet to our router. Our router, they validate their session, and then the router will allow them to pass through at that point to access the resources on the other side for a max of 120 minutes. We have the IP address set on the interface, and then we apply this access list to the interface itself. The last step is specifying the type of logon. So we're just using line VTY0 for this, one of our Telnet lines. Logon local, so we're setting everything up to locally log on, and auto command. This is where it allows us to create the temporary access list. Access enable, so it's automatically going to create a temporary pass-through access list entry, enabling access, with a timeout of 5. This is 5 minutes, and this is an idle timeout. So if they're active on the session, the max they're going to get is 120 minutes. If they don't use the session or whatever, they're idle on it, it's going to stay open for 5 minutes. So it's not going to stay open forever waiting for somebody else to go through and use that session and try to break our security. So again, 4 steps: create the dynamic access list, apply it to an interface, specify authentication, and enable the ability for temporary access through the router by using that auto command. And again, it's just going to create a temporary entry. Let's go in and take a look at the next type of access list. Here is the reflective, or again you can call it reflexive, access lists requirements and the sample configuration. Define the reflexive access list and apply inbound or outbound. Nest the reflexive access list in the opposing access list and set a global timeout value. So what you're doing, and again this situation allows traffic from a remote server back through temporarily because you initiated the session from a client inside of the network. So here's our router, and here is our serial 00 interface. So what we're doing is we're creating an outbound filter to create dynamic entries that will allow inbound traffic from this server when I request it. So the first thing we do is we create the extended access list called outbound filters, and we go in and permit TCP. So any TCP traffic, this is what we're going to generate the reflective entries for TCP only, not UDP. So for TCP traffic, for any source, any destination, we are going to reflect the session. So the outgoing session will be reflected on the way back in, and it will be called TCP traffic. That's the name of it's basically like a small database of entries, or an additional access list of entries that are going to be allowed on the way in temporarily. IP access list extended inbound filters, so that's going to be the inbound access list. We're going to block pings, just because we always block pings. And what we're doing here is it says evaluate TCP traffic. So remember, TCP traffic is an additional temporary access list that will have entries based on client initiated sessions from inside of your network. So each client that goes out and accesses a resource, an entry into TCP traffic will be put to temporarily allow access through serial 0. Then what we do is we go in and apply both to the serial 00 interface. Inbound filters on the way in, outbound filters on the way out. IP reflective list timeout. So for a couple of hours, those entries will be inside of the TCP traffic database. So what happens when a client here goes in and goes out and accesses a resource on this server? Again, let's use an IP of 10.1.5.9. This guy will use an IP of 20.3.2.80. So he goes out, accesses resources on the server. When he initiates the connection to IP 10 or 23.280 at whatever port number, what's going to happen is, because we've told it to reflect traffic on the way out to any destination from any source and put that entry in TCP traffic, we're going to allow inbound traffic with this source IP to this destination IP, and we're going to put that entry right here into TCP traffic. What's going to happen when the server responds, because of this access list right here, evaluate TCP traffic on the way in, the packets hit this interface right here. It says evaluate TCP traffic. TCP traffic has an entry in it saying, okay, traffic from this source IP and port number can go to this destination IP and port number. I'm going to allow it. It allows the traffic to come back through. After a couple of hours, that entry will time out, so somebody else can't go in and spoof this IP or whatever, or get on this machine and try to get into our network. So that's how reflective or reflexive access lists work. Let's go in and take a look at the timed access list. For timed access lists, there's just a couple of things you're going to do. You're going to go in and set a time range, and then you're going to incorporate the time range into a permit or deny statement within an access list. Here's an example. Time range, and I'm going to call it no web. So I'm getting rid of web access with this, but I could do anything with it. But this is the time range I'm calling it. And I can do something like an absolute start. So I pick a start time and a start date. So 4:30 a.m. on June 15th, 2007. This will apply. Absolute end after 4:30 a.m. September 15th, it will no longer be valid. And so what I do in the access list is I am denying any source, any destination traffic at port 80, time range, no web. So what it does is it applies these time restrictions to this statement in the access list. The additional one, you can use a different variable here, time range, no FTP. It takes me into the time range configuration. I go periodic, And I can specify days of the week, beginning days, stuff like that, Fridays. I chose weekdays here. I could also do weekends. So on weekdays, 8 a.m. to 7 p.m., and I apply that time range to my access list here. Deny TCP, any, EQ, FTP, time range, no FTP. So all FTP traffic will be blocked on weekdays, 8 a.m. to 7 p.m. And again, to reiterate, all web traffic, because that's here with a deny, will be blocked between 4:30 a.m. the 15th of June to 4:40 a.m. the 15th of September. So that's actually 4:40, not 4:30 there. And then again, I just apply it to individual statements within the access list. Never forget your permit statements. All access lists need at least one permit statement. So let's go in and do a recap of what we've talked about in this video. So within this access list configuration expanded version for the new CCNA, we have talked about sequenced access lists, which is going to be a bigger part of the test than the additional types down here, where we can actually go in and sequence our access list entries. And again, it's a good idea if you are using sequences in your access list entries to spread them out. That way you can go in and fit things in between if you need to. The additional types we talked about, dynamic. Again, that creates a dynamic entry. So when I go out or someone's trying to come in to get resources on a server here, they first need to go in, telnet to the router, get validated, and then the router will allow them to pass through, also called lock and key. Reflective would be when I access a server remotely, would be one situation. My client goes out to the server, the outbound access list looks at it and creates a reflective entry inbound so the server traffic can get back through temporarily. And then also we've talked about time-based access lists, where we can set time restrictions on when particular access list entries are going to be in effect.